Okay, good morning everybody. So today is gonna be probably, I guess, our last in-person class. So before we start, let me have some announcements. Monday's class is asynchronous. Okay, I'll send you an email about what that really means. Basically, I'm going to post a video onto the YouTube channel. I'm not going to cover any more content from the book, so probably it'll just be something either diving in a little bit more detail into something that we've already done, or maybe I'll review some concept which I feel like some students are still struggling with, or maybe I'll do something extracurricular. But you won't need to actually come and meet in person on this coming Monday. The following Monday, we will have one more asynchronous class, which will take the form of a review. So I guess what I'm going to do that day is try to pick some key problems which I think students have struggled with, and try to kind of tailor the review for the final exam just based on, I guess, what I know of your guys' performance so far. I suppose I could, maybe what I'll do is send out an email and ask for questions if you guys have specific questions, or if you have specific things that you want to see in that video, then I can get an email from you guys about what you want to see, and I'll put it in the video. So, any questions about like logistics of the course? Yeah?
On reading days, are you still going to be like, is the MTC still open?
Ooh, good question. Kyler, you know?
I would think that they probably wouldn't show up if they have an excuse to not show up.
Yeah, I don't know. I plan on being in the math tutoring center on the reading day that Friday. So, maybe?
On some of the reading days, there's the Student Success Center holds like it's called like Finals Frenzy, where a bunch of like SIs for business calc and any other class that has SIs, they hold like long review sessions for finals. I'll send out more information when they give that to me, but that's also another like review resource.
Okay, so for those of you at home, the question was regarding the reading days, whether tutoring was going to be available in the tutoring center. The answer is maybe. I'll be in the tutoring center during my usual time for sure. So you'll have that as an option, but there's also SI meetings all that week for extended periods of time for students to study for finals. So Erin is going to send out an email about that when she has more information. Okay, any other questions about like logistics and stuff? Okay, then we're going to return to our discussion about one more announcement. I'm going to grade the exams over the weekend. I haven't had an opportunity to grade them yet. Okay. So we're going to return to our discussion about average value. So here was our note box. We said that if f of x is a continuous function on some interval, then the average value of f of x is going to be given by this integral, which looks kind of like an average type of thing. We kind of sum up the area and we divide by the length of the interval. Okay, so what I want to do is give you a little bit of graphical intuition to remind you of what's really going on here. It's kind of like if we had two boxes. Okay, here's box number 1. And then we have some other box which is much shorter, but the same width. And the question is, so if this is, let's say this is 10 and this is 5, and they're both 2 units wide, then the question I could pose is, what is the average height of the boxes? So the previous approach that you might have learned in high school is take the heights, add them, and divide by 2. And that works for this situation. We could just take, 10 plus 5, divide by 2, we get 7.5. But our new strategy is to do the following. Add the areas, then divide by total combined width. Okay, so this one has area 20, and this one has area 10. So what we're going to do here is take these two areas and add them together. We'll get 20 plus 10 equals 30. That's the total area. Now what we're going to do is we're going to take area and we're going to divide it by this purple quantity, which represents the total width, the total combined width if I were to put all of my boxes side by side. Okay? So that's going to be 4. So I'm going to take 30 and divide that by 4. I'm going to get the same thing, 7.5. Okay, so on an example like this, what's really happening here is we say, let's find the height of a box whose area is the same as the combined area between these two blue rectangles and has width equal to the sum of their widths. So we're really after this rectangle right here, okay? This pink one. Okay, so what we're doing is we're saying we know what the area of this pink rectangle should be. It should be the same as the sum of the two areas of the blue rectangles. And we know what the width of the rectangle is. So if we know what the width of the rectangle is and we know what the area is, then we can find the height, because we know that area is just going to be the height times the width, or width times length, however you want to put it. Okay, or maybe we should call it base. You guys are used to seeing base, so we'll call this base times height. And we know what base and area are, so we can solve the equation 30 equals 4h, and that gives us h equals to 30 over 4. Okay, so this is the process that we're doing here. And it seems at first like it's kind of more complicated than what we were doing before. Okay, except for the fact that this new method, okay, can handle more complicated setups. Okay, this initial setup that we had is not complicated for a couple of reasons. First of all, they are just rectangles, right? And it's totally dependent on the fact that these are rectangles. It's also completely dependent on the fact that these rectangles have equal width. Okay? So if I were to draw something a little bit more complicated, like, let's see, add a page here. If I were to draw something a little bit more complicated, I could give you two rectangles which have different width. Now if I want to find the average, quote, average height of these rectangles, what I'll need to do is I'll need to sort of weight the smaller one less, is kind of how you can think about it. Okay? And furthermore, what it allows us to do is then, if we have some kind of really wonky shape, what we can do is just take Riemann sums, which are close to the actual area under the curve. And if we find the average height of the rectangles in the Riemann sum, it will give us something close to the average height of the actual function. Okay, so that is about as well as I can recap the intuition behind this. Okay? So let's try some more problems. We'll try problem 3 together to warm up, and then problem number 4 we'll do on our own. I need my calculator for this one. Okay, so we have a city called Flatland, and the population of this city after 2015 can be tracked by the function p equals 124 times e to the power 0.5t. And t is measured in years since 2015. And what we want to know is the average population of Flatland between 2016 and 2021. So let me remind you that the average value formula is 1 over b minus a times the integral from a to b of f of x dx. Okay? 1 over b minus a times the integral from a to b of f of x dx. So here we have a function, it's really the function p of t. And it's equal to 124 times e to the 0.5t. And we need to know the average value of this population between the years 2016 and 2021. Okay? So first I should figure out what is A and what is B. Well, they should be values of t, okay? They should be values of t. And we want to go from 2016 to 2021. Now, in terms of t, 2016 should be interpreted as number of years since 2015. Well, 2016 is 1 year since 2015. And 2021 is going to be 6 years since 2015. So we have a and b. We have the function. All that's left to do is use this formula. We're going to do 1 over 6 minus 1 times the integral from 1 to 6 of 124 e to the 0.5t dt. Okay, so now I have an integral, and I can integrate this in one of two ways. I could try to use the e to the kx rule if you memorized that, or I could try to use u substitution, where we would choose 0.5t to be u. Okay, I'm just going to use the e to the kx rule since we learned it. This is going to be 1 over 6 minus 1 still. In fact, why don't we pull that 124 out? And what I should write now will be the antiderivative of e to the 0.5t. It's going to be e to the 0.5t divided by 0.5. That comes from the e to the kx rule, and we should evaluate at 1 and 6. Okay, so this is going to be dividing by a half is the same as multiplying by 2. I'm getting 248 over 5 times e to the half of 6 is 3. And I'll subtract from that half of 1, which is just, I guess, the square root of e. Okay, so then if you really want, you can plug this into your calculator and get some decimal. So what did we do here? First of all, we had to take a word problem and interpret it in terms of a, b, and our function. And then we had to plug those values into our average value to understand what the average population would be between 2016 and 2021. And there's a little bit of nuance, I guess, or subtlety involved in remembering that when we want to go from 2016 to 2021, we should consider these as values of t, where t is in years since 2015. So that's how we got 1 and 6 for A and B. Then after that, we had an integral, standard looking integral. We can solve it using U substitution, or we can solve it using the e to the kx rule, your choice. Any questions about that problem? No? Feeling good? Okay, sweet. All right, well, let's try this problem on our own for, I don't know, 2 or 3 minutes. I'll give you longer if you need. And let's try it out, and then we'll work it out together as a class. All right, does anybody need more time to finish up? All set? Okay, so we want to use this graph of the function f of x here to find the average value or average height of the function on the interval from 0 to 8. So, should I use my average value formula? Yeah, probably. Okay, so let's set it up. It should be 1 over b minus a times the integral from a to b of f of x dx. What are a and b? Yeah, what?
0 and 8.
Yeah, they're going to be 0 and 8, so we can plug that in. 1 over 8 times the integral from 0 to 8 of f of x dx. And now, how do I compute this? Yeah, Alice?
You can just count the boxes.
Yeah, you can count the boxes, or we can take a little bit more nuanced approach and just find the area of a triangle here. And then the area of a triangle here. And what should I do once I have these areas? Add them?
Subtract.
I should subtract the one that's beneath the x-axis from the one which is above the x-axis. Okay, so this one looks like it has height 3 and width 6, so 1/2 times base times height is going to give us 1/2 times 6, that's 3 times 3 is 9. So that's the area of that triangle there. And then if we want to find the area of the triangle beneath, then we can just do, what, 1 times 2 divided by 2 is just 1. Okay, so we get, what, 1 over 8 times, what should my integral from 0 to 8 of f of x dx be? Yep.
8.
Yeah, just 8, right? Okay, so maybe I'm boring you guys with this problem. It should just be 1. That's the average value of this function. So what is this really saying? If we know that the average height of this function is 1, it's like saying if we took an unlimited number of line segments, okay, and each line segment had the height of our function. And if we just did that all the way up, right? And if we took this unlimited number of line segments, we added up all of their heights, and then divided by the number of them, we would get the average height of this function, okay? The way we approximate that is by taking the heights of these rectangles, right? And we know that if we take these rectangles and we make them really, really skinny, they're going to look almost just like these little lines, segments. Okay, so that's kind of the process that we're doing here. Okay. Any questions about that problem? Yeah, Kevin?
So you showed us at the very beginning that we could just add the areas and then divide by the total combined width.
Mm-hmm.
And if you do that from this problem, you get the same answer. So could we have just done that instead of writing everything out?
Yeah, sure. I mean, that's literally what we did. I mean, this 1 over 8 here that we multiplied out front, that's dividing by the total width of our interval, right? And this integral from a to b of f of x dx, we actually computed it by adding the areas of these triangles, right? So to answer your question, yes, that is we absolutely can do that, and that is what we did. We just wrote it in kind of a funny way at the start, and by the time we got to this point here, we were doing what you were saying. So yeah, that's kind of the power of this method, is it works even when our shapes here aren't necessarily evenly sized rectangles. Okay? All right, good question. Any other questions? All right. Well, we'll go on to problem number 5 here. Okay, so we have some function here. It looks like a polynomial. And what is it measuring? It's measuring the rate of sales. Okay, so the rate of sales in sales per month. Okay, where T is in months. All right, so step 1, we want to estimate the total sales during the first 6 months of the year, and then in the last 6 months of the year. So total sales. Should I apply my formula 1 over b minus a times integral from a to b of f of x dx to this problem? Ryan's shaking his head no. Why not?
It's not the average.
Yeah, we're not looking to find an average value here, right? We want to know a total number of sales when we're given the rate of change of sales. Okay? So if we want to know the total sales in the first 6 months, so from month t equals 0 to t equals 6, and we have a rate of change of sales, what should I do to find the total sales between these months? Kevin?
You just plug them in.
Pl-
and then-
Plug them into r of t.
Yeah.
So just take r of 6 minus r of 0, something like this.
Yeah.
Okay, not quite. That would give us the change in the rate of sales between those 2 points. Yeah, Alice, you have an idea? Yeah, we should find the integral, right? This is kind of like those problems where they say we're driving 80 miles per hour and we do it for a certain amount of time. How far did we drive? Okay, that's kind of the situation here. So what we're going to do is not quite r of 6 minus r of 0. That would give us the change in the rate of sales. What we're going to do is the integral from 0 to 6 of r of t dt. Okay, so I guess we're just going to do the... Okay, we will do both of these then. Let me move it over. I'm going to need more space here. Integral from 0 to 6 of r of t dt. Well, that's the integral from 0 to 6 of t cubed minus 12 t squared plus 16 t plus 100 dt, and that'll be equal to, I think we all can do these power rule things here. We're going to get t to the 4th minus t cubed over 4, no, it's not over 4, times 4, 4t cubed, plus t will become t squared divided by 2, 8t squared, and then we'll add 100t. We will evaluate at 0 and 6. But I only really need to worry about plugging in 6, because when I plug in 0 for t, well, t to the 4th and 4t to the cubed and 8t squared and 100t, those are all going to just be 0. So we'll get, I don't know, 6 to the 4th minus 4 times 6 cubed plus 8 times 36 plus 600. So whatever that number is. And this should have been t to the 4th over 4. So 6 to the 4th over 4. Sorry about that. Okay, so that's going to be our total sales during the first 6 months of the year. And if we want to find the total sales in the last 6 months of the year, we should do another integral. It should be the integral of r of t dt. And what should our bounds be for this one? Yeah, Wyatt?
6 and 12.
6 and 12, right? Last 6 months of the year, we should go from 6 to 12. Okay, good. And when we do this, we're going to have the same kind of process, and we're going to get something like 12 to the 4th over 4 minus 4 times 12 cubed plus 8 times 144 plus 1200 minus, well, if we plug in 6, we're going to get the same thing that we got when we plugged in 6 for this one. So we'll get minus 6 to the 4th over 4 minus ... you know, this stuff here. Okay, and if we want to answer what is the total amount of sales for the entire year, well, that's just going to be the integral from 0 to 12 of r of t dt. And I claim that we're actually not really going to have to do much more work other than an addition problem here, because we know that the integral from 0 to 12 of r of t dt is going to be just the integral from 0 to 6 of r of t dt plus the integral from 6 to 12 of r of t dt. Remember, we had that rule because, because we said that if we have some function here and we consider these two areas from a, b, and c, well, the integral from a to c is going to be equal to the integral from a to b plus the integral from b to c, because the integral from a to c represents this entire area, whereas the other integrals represent just the pieces. So if we add the two pieces of area here, then we're going to get the total area. All right. So that's how we find that, and it's just going to be, well, it's going to be this orange piece, and then we're going to add to that the green one. So if we add back what we subtracted, we'll wind up with just 12 to the 4th over 4 minus 412 cubed plus 8 times 144 plus 1200. Okay, so far, just review. And now what are we supposed to do? We're supposed to find the average sales per month during the year. So what should we do now? Any ideas? Yeah?
And use our average value function.
Yeah, we should use our average value function. What should A and B be?
0 and 12.
Yeah, 0 and 12. So we should take the integral from 0 to 12. And what goes in my blank? What should we integrate here? Yeah, Kevin?
R of t.
Yeah, just r of t, right? So r of t dt. And am I done? Just figure out what this is? No, I'm missing something. What am I missing, Kevin?
Use 1 over 12 minus 0 at the beginning.
Yeah, we should have 1 over 12 minus 0 at the start. Very good. Okay, so what is this telling me? This is telling me that I just take the integral from 0 to 12 of r of t dt. Guess what? We already did that. Right? We already did that in the previous problem. So I should just take that number and divide by 12. So I'll get 12 cubed over 4 instead of 12 to the 4th, minus 4 times 12 squared, plus 8 times 12, plus 100. Okay, sweet. So this was a little bit of a callback to, I think it was section 5.5. We learned that if we have some function which is a rate of change, and we integrate that function over some interval, that will give us the total change in the quantity during that time period. Okay? So this is really similar to those problems where they give us the velocity of some object, and they want to ask us between seconds 5 and 10, how far did the object travel? Something like that. Okay? It's just repackaged a little bit in terms of business. Okay? Any questions about A, B, or C? All good? Okay. Then, let's see. This is getting a bit tedious. Maybe we'll do 1 or 2 more. The average value of this function on the interval 0 to 2. Well, that one's kind of a gimme. Average value of a function on an interval from 0 to 2, we know right away we should just do the integral from 0 to 2 and just 1 plus e to the x. So I get 1/2 antiderivative of 1 plus e to the x. Can anybody give me that? Yeah, why?
Just e to the x.
Just e to the x for the second part.
Sorry.
What about the first part here?
Oh, x.
Yeah, just x. And then we'll evaluate at 0 and 2, so we'll get 1/2 times, when we evaluate at 2, we will get 2 plus e squared, and then we will subtract from that and plug in 0, we'll get 0 plus e to the 0 is 1. So we get 1/2 times 1 plus e squared. All right, that one was not too bad. Any of these harder? Oh, here's a good one. Let's do this one, problem number 3. All right, in 2020, we put 5,000 in a bank, and it's paying us 3% interest annually. Okay, so I guess you guys are maybe having flashbacks to, like, I don't know, the second week of class or something when we learned how to do interest. So this will be good for final exam review, see if we can remember how we find out this function, which is going to tell us our amount after t years. Okay, so we should have some function We usually use the letters P of t, I think. And before, I'll just remind you, we had two ways of doing these interest problems. We had annual interest and then continuous interest. The formulas were P naught times a to the t and P naught times e to the kt, if I recall. Sometimes in the financial world, we use delta here instead of k. Okay, so which one should we use for this problem? Yeah, Kevin? Yeah, P naught a to the t, because we're computing interest annually, okay? What that means is at the end of each year, we take your current balance, we multiply times some number, and that's your new balance. And we do that once per year. So we should use annual interest. And what should my value P naught be? Yep, 5,000. And now I should multiply by something. Does anybody remember the equation we had to figure out what A was?
Is it A equals E to the K?
Not quite. It will be if we used continuous interest. Or rather, that was how we equated continuous interest with annual interest. If I know what R is, yeah?
Is it 1 minus R?
Not quite. 1 plus R. So in our case, it's going to be 1.03. And if you don't quite remember what A should be, and if you got mixed up with 1 minus R or 1 plus R, that's okay, because you're going to notice pretty quickly that if we had 0.97 in here and we multiply 5,000 times something which is less than 1, we're going to get a number which is smaller, right? And that's going to make our bank not very good because they're taking money away from us. Okay, so we should use 1.03, and then we just need a power t here, and we're done. So that's a review of annual interest. And now we're asked to find the average value of the account over the time period from 2020 to 2050. Okay, so we should figure out what A and B are. And here, the time period is from 2020 to 2050, and T is measured in years after 2020. Well, 2020 is exactly 0 years after 2020. And 2050 is 30 years later. So what we should do is take the integral from 0 to 30, 5,000 times 1.03 to the power t dt, and out front we should have 1 over 30. All right, now I'm going to ask you guys a hard problem, hard question, which is, does anybody know how to integrate this? I believe I've done it once in class before. If you don't remember, that's okay. It actually has to do with what Wyatt was saying earlier. A equals e to the k. Yeah?
Is 1.03 gonna be E to, it becomes K, sorry.
Yeah, exactly. We're going to replace 1.03, this function which I don't actually know how to find the antiderivative of, 1.03 to the t. We're going to replace it So what we're going to write instead is, we're going to keep everything the same, 1 over 30, integral from 0 to 30 of 5,000. But we're going to replace 1.03 by something which is equal to 1.03, but has the form e to the blank. Okay, so I'm going to write e to some number. And if I take e to some number and I get 1.03, what's the simplest thing that that number could be? Well, I guess maybe it's not that simple. Anybody have ideas? Emily?
Is it ln of 1.03?
Very good. It should be ln of 1.03. And now what I can do is I can just, really I can just get rid of these parentheses, right? If I take something, some number to a power, the thing that I do with my powers is multiply them. So I'll just make this, I'll just move this over a little bit. Come on. Ooh, that's not what I wanted. Okay. You know what? Fine. So it's just imagine that these things are being multiplied here. And now if I want to integrate this, all I have to do is use the e to the kx rule. Okay, so it's going to be 1 over 30. 5,000 is going to hang out. And then I'll take e to the same exact thing. And I'll divide by k, which in our case is ln of 1.03. And then I will evaluate this at 0 and 30. And just to wrap this up, the way I could write this would be 1 over 30 times 5,000. Well, why don't we just make it a little cleaner? We'll make it 5,000 over 30. And I'm going to change e to the ln of 1.03 to the power t back to 1.03 to the power t. And divide by ln of 1.03. And then evaluate at 0 and 30. And that'll be equal to 5,000 over 30 times ln of 1.03 times 1.03 to the power 30 minus anything to the power 0 is 1. And this was using the fundamental theorem of calculus. All right, so pretty instructive example here. I think we incorporated annual interest, average value, integration, either by u substitution or by e to the kx rule, and this kind of important concept which we learned in several classes, which is this relationship between 1.03 and e to the ln of 1.03, the fact that e and ln are inverses of one another. Okay, any questions? All right, if not, then we're done for today. Thanks for taking the class. See you when I see you. Yep.